Hello, this is Mr. Waters again, and I am going to do some more examples of the homework from pre-calculus, and this is from page 663 about rotated conics. I'll do first a couple of examples, three examples about calculating the necessary rotation angle. And specifically what we're doing is we're calculating the angle of rotation needed to rotate the x and the y-axis so that a conic equation in terms of x and y with an xy term is transformed into an equation in terms of x prime and y prime without an x prime y prime term. In other words, we're going to take the ordinary xy axes and rotate them a certain angle theta so that the conic section in terms of the new axes x prime and y prime is no longer rotated. It's neatly horizontal or vertical so that we can do the usual analysis on it. Okay, so first let's try doing this equation here. We'll start with 2x squared plus 3xy minus 4y squared plus 3x minus 2 is equal to 0. Okay? Now, the general conic section equation or formula is a x squared plus b xy plus c y squared plus dx plus ey plus f is equal to 0. And our rotation formula, the formula we use to actually calculate the rotation angle, is the cotangent of 2 theta, where theta is the rotation angle, is equal to a minus c over b, where that comes from a, b, and c in the formula. So we can see in the equation we started with, the a is 2, the b is 3, and the c is negative 4. So the cotangent of 2 theta is equal to 2 minus negative 4 over 3, which is 6 over 3, or 2. Now, so we've got cotangent to theta is equal to 2. So in order to actually do that on our calculator, we'll take the reciprocal of both sides, and that'll give us the tangent of 2 theta is equal to 1/2. Now on the calculator, we use the arctan function to free the theta from the tan expression. So 2 theta would be equal to arctan 1/2, which as it happens, 2 theta is equal to 26.56, or about 26.6 degrees. Divide both sides by 2. 26.6 divided by 2, and that's going to give us 13.3 degrees. So theta, our rotation angle required to perform the rotation of this, is going to be 13.3 degrees. Now let's go ahead and let's try another one. Let's say we've got this equation here, 2x squared plus 4xy minus 5y squared plus 2y is equal to negative 7. Well, we're still going to go ahead and use our rotation angle. Okay, here is our rotation formula. There's the a, there's the b, and there's the c. So cotangent of 2 theta is going to be equal to 2 minus negative 5 over 4. Looks like that's going to be 7 over 4. And so that's going to give us, so cotangent, so I'll start over here, cotangent to theta is equal to 7 over 4. So we arctan both sides, so 2 theta, or rather, first we take the reciprocal of both sides, because we can't really do cotangent on our calculator, so the tangent of 2 theta is going to be equal to 4 over 7. So now we arctan both sides, and my calculator says that arctan 7 divided by 4 is about 60.2 degrees. So 2 theta equals to 60.2 degrees, or theta is equal to 30.1 degrees, the required rotation angle. Okay? Now, let's try another one here. Let's say that we have got x squared minus 3xy minus 5x, or 5y squared, minus 4y is equal to 2. Okay, here, using our formula, the cotangent of 2 theta would be equal to the a, which is 1, minus the c, there's the a, the c, which is negative 5, over negative 3. Okay, 1 minus negative 5 is 6, over negative 3, that's going to give us negative 2. So now we've got cotangent 2 theta is equal to negative 2. Or, flipping both sides of the equation, tangent 2 theta is negative 1/2. So now what you do is you go ahead and you arctan negative 1/2. And I'm going to do shift tan, and that's negative 26.6 degrees. So the tangent, so 2 theta is equal to negative 26.6 degrees. Well, the thing is that when our rotation angle wants to be the smallest acute angle possible. So we don't really want to have a negative rotation angle. So what we're going to do is we are going to add 180 to that to get the same angle. Well, actually, before that, first we're going to go ahead, we're going to add 180 to that, okay, and get 153.4. So 2 theta could also be equal to 153.4, because the 26.6 negative and 153.4 positive, they've both got the same tangent. We want to use the positive one. So now we divide both sides by 2. See, let me make sure I've written that in here. We're going to add 180 and get 153.4. Divide both sides by 2, and that's going to give us 76.7 degrees. So for this conic, theta, the necessary rotation angle is 76.7 degrees. And so that is our rotation angle. We will do one more. That's a little bit different than the other ones. And one may come up like this. So here is our last example. We're going to try 3x squared minus 4xy minus 3y squared plus x plus y minus 3 is equal to 0. Okay, now looking at that, we see that the a term is 3, the c term is, oops, I'm going to make that positive 3, sorry. So it's going to be 3x squared minus 4xy plus 3y squared. So that's going to be plus 3y squared, that's the c, and then the B is -4. So calculating the angle, the cotangent of 2 theta is equal to 3 minus 3 over -4, which of course is equal to 0. So we've got the cotangent of 2 theta is equal to 0 over -4. We flip the equation, okay, and that's going to give us tangent. That is, by flipping the equation, I mean finding the reciprocal of both sides. So tangent of 2 theta is equal to -4 over 0. Now again, we'd like to just arctan both sides to free the theta from inside the trig expression there, but we can't because -4 over 0 is undefined. So we can't, our calculator won't do that. We can't arctan an undefined expression. So what do? Well, we think, okay, well, wait a minute. What's the angle that has, what's the smallest, the simplest positive angle that has an undefined tangent? Well, it's 90 degrees. So we're going to say 2 theta would have to be 90 degrees. Divide both sides by 2. Theta is equal to 45 degrees. So for that conic section, whatever it is, the required rotation angle in order to make it vertical or horizontal neatly is going to be 45 degrees. Anyway, that should about cover it, and thanks so much for